Okay, so taking it up one notch in difficulty for the hyperbola, a slightly less basic version when you're trying to find an equation but they haven't given you all the information you need. So in this case, you see we've been given a hyperbola graph. There's no grid lines on it, so it's really hard to read actually exactly what the values would be. They have given you a few points. You can see them there as little gray dots. And so for this one, what I'm going to do is, if possible, if I actually have enough information in there, is trace in where I think the asymptotes should be. And if I look here for the horizontal one first, they're probably going to go through 2. You'll notice that if I trace that out, it splits the difference really nicely. If you can get a straight line, use a ruler if you have it, on both the left and right hand side of the hyperbola. So I'm going to say that my horizontal asymptote there is going to be at 2. That's y equals 2. And for the vertical, I'm going to take a look at this, and it's not going to be really close to that one. Scroll down a little bit, you can see what's going on. But you'll notice here that it's kind of splitting the difference. If I used 2, I would cross the graph, so that's not going to be appropriate. So let's try 1. And if I draw in this case, x equals 1 for my vertical asymptote, that looks to be about right. So again, looking here, I've got x equals 1 for vertical, and I've got y equals 2 for horizontal. So that tells me that my horizontal is going to be that my b is equal to 2, and my vertical tells me always that the c in the formula is equal to the vertical, so c is equal to 1. Remember, your basic formula is going to be a over x minus c plus b. So I've got b and c sorted. The next thing is to try to sort a. And to find a, you actually have to do a little bit of work here. So pick a point that you can read on the graph. So I'm going to pick one that I know exactly, and that's going to be this guy here. I know that that's an x of 0 and a y of negative 2. So that's the point I'll use. I'm going to plug the x and y values of that point into the equation and solve it. And you can do that by hand or using solver. So first things to do is I'm going to replace the c and the b because I already know those. Y is equal to a over x minus 1 plus 2. That's the c and the b that I know from my asymptotes. Now, the reason I can't go with the other method of going from the cross, counting over 1, and then going up is that I can't really read very precisely on this graph what that value would be for a, so I need to just use the algebra to back it up. So I'm going to take that point of 0, negative 2, and I'm going to plug it into the equation for x and y. Remember, it's always x first, then y. So I would say negative 2 is equal to a over 0 minus 1 plus 2. And now, time to solve. You can use solver if you like, and if you do, you need to make sure that you put brackets around that, or that you simplify it first. I'm just going to go through with the algebra though. So I know that that's negative 2 is equal to 0 minus 1 is just negative 1, and a divided by negative 1 is going to be negative a plus 2. So subtracting 2 from both sides, minus 2 gives me negative 4 is equal to negative a. And divide both sides by negative there, I know that 4 is equal to a. So now I can write out my full equation. Y is equal to 4 over x minus 1 plus 2. Where my vertical asymptote is x equals 1, and my horizontal is y equals 2. Again, this point here happens to be my y-intercept, which is convenient as well, and the x-intercept would be here. I'm going to guess that's halfway between, that should probably be negative 1 comma 0. But again, if you're not sure, just plug in 0 for y and solve for x, or put it into graph and use gsolve. Okay.